So even and odd polynomials. A function is considered even if it is symmetric over the y-axis. So if you have a graph that is even, or given the function expression, one way that you could you they'll show you an example doing it that algebraically. It's easier to test out a number, which is what we'll do most of the time. It's odd. If the point xy is on an odd graph, then negative x, negative y is also on the graph. So if you replace every x with a negative x and you simplify it and do all the algebra steps to make it look nice and neat, if every sign is opposite of what your original real quick. So 2, -3. That point is on my graph. I have the point 3, 1. If it is even, I should also have the point -3, 1. And I do. So for an even function, you have 2 points where the x values are opposite signs, the y values are the same. I could test that out all day long. If I were to cut this picture out and fold it right on the y-axis, my graph would overlap. So that makes it even. Okay. Looking at number 2, what do you think it's going to be? Even, odd, or neither? It's probably going to be neither. All right, so let's find a point 3, 1. If it's an even function, I should also have the point -3, 1. Do I have the point -3, 1? No. If it is odd, I should have the point -3, -1. Do I? No, I don't. So this one is neither. If I fold my graph, fold the picture right on the y-axis, it does not overlap. If I turn my page upside down, that does not look exactly the same as it did the other way. So it's neither. Looking at number 3, even, odd, or neither, what do you think? We think it's going to be odd. So I have the point, I don't have any good points here. So that's the point 2, 0. If it's odd, and I change both signs, I should have the point -2, 0. Yes. This point, about 1, -3. I should have the point -1, +3. Do I? I do. It's not right at a maximum or minimum. That doesn't matter. If I had the actual equation of this, I could put both of those in my calculator and look at the table to see what points pop up. Okay, but this one is odd. If I turn my graph upside down, it looks exactly the same. Let's test some out using the equations. So the easiest way to do it is to test a number. Okay, if I give me a number between 2 and 10. 2, okay. So if we plug in x equals 2 and x equals -2 and look at the y values. If the y values are the same, it's an even function. If the y values are like +5 and -5, +12 and -12, it would be odd. If they're two totally different numbers, it's neither. So if we find f of 2, now if we ever happen to plug it in and get 0, you need to try a different number. Just try plugging in something besides 2. All right, but f of 2 try to do some of these without your calculator. So you do 2 to the 4th first. 2 times 2 is 4 times 2, 8 times 2, 16. So 2 to the 4th is 16. What's 2 times 16? 32 minus 2 squared is 4 plus 5 is 33. So f of 2 equals 33. And then try f of -2. -2 to the 4th. When you raise a negative number to an even exponent, is your answer positive or negative? It's positive. -2 to the 4th is still +16 times 2 is 32. Minus negative 2 squared is still 4. Plus 5. It's exactly the same. So since my y values are exactly the same, that means that I have an even function. So it does from there look like it's symmetric over the y-axis. Okay. Let's try number 5. F of 2. I would generally always use 2 just because you're going to be using smaller numbers, and you likely would not get a calculator on this part. 2 cubed plus 3 times 2 minus 1. 2 cubed is what? 8 plus 6 minus 1 minus, why did I put 5? Minus 1. You get 13. F of negative 2. Negative 2 cubed plus 3 times negative 2 minus 1. What is negative 2 cubed? Negative 8 plus negative 6 minus 1. Negative 8 and negative 6 is negative 14. Minus 1 is negative 15. I have two totally different numbers. That makes it neither. Any questions? Number 6, f of 2. 2 squared plus 2 minus 12. That would be 4 plus 2 minus 12. 6 minus 12 is negative 6. F of negative 2. Negative 2 squared is what? Positive 4. This will be minus 2 minus 12, which is negative 10. Two totally different numbers. It's neither. Number 7, f of 2 2 to the 5th. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So 32 minus, and then we have 4 times 2 cubed is 8. This one is going to give us 0. That's not going to help us. So let's pick a different number to plug in. Let's try 3. All right. I love the lettuce, but I didn't pay for the lettuce. All right. 3 to the 5th. Ooh. 3 times 3 is 9. Times 3 is 27. Times 3. 27 times 3. All right, here's how you do it in your head. What's 20 times 3? 60. And 7 times 3, 21. 60 and 21 is 81. All right, 81, so that's 3 to the 4th. 3 to the 5th, 81 times 3. What's 80 times 3? 8 times 3 is 24, so 80 times 3 is 240. And then you got the 1 times 3, so it'll be 243. So this is 243. That's why 2's are a little bit easier. Minus 4 times 27. 3 times 3 is 9. Times 3 is 27. $80 and 28 is 108. If we subtracted 243 minus 108, we would have 143, 135. F of negative 3, negative 3 to the 5th, minus 4, negative 3 cubed. So negative 3 to the 5th, when you raise to an odd power, your answer is negative. So it would be negative 243. And this would be negative 27. If you solve this, this would be negative 243 plus 108, which would be negative 135. And so see how I have a positive and a negative 135? That's what makes it an odd function. Try numbers 8 and 9. If you need to use your calculators, that's okay. Alright, these should work out to be number 8 is even and number 9 is odd. I think on number 8, if you plug in a 2 and a negative 2, you get positive 8 for both. And then on number 9, you would get a positive and a negative 10. I think that's how it worked out. Let's turn over. Number 10, half of the graph of an odd function is shown below. We want to sketch the other half. So odd function means that negative x, negative y. I take 1 point that's on my graph. I also have the negatives of the x and the y. So if I have the point 2, 3, I also have negative 2, negative 3. If I have the point 1, negative 5, I also have negative 1, positive 5. So the easiest way to do this is to just pick out several points. For example, this is 0, 3. This is 3, 0. I'd probably also try to get somewhere in between. So like 2, 2.3. I just kind of estimated there. 5, negative 1, 7, negative 2. So if it's an odd function, I should be able to graph these but change both signs. So this would be negative 0, which is just 0, negative 3, negative 2, negative 2.3, negative 3, 0. So that's this curved part. And then negative 5, positive 1, negative 7, positive 2. So, about like that. So if I turn my paper upside down, it looks exactly the same. It's an odd function. If the point 3, negative 18 is on the graph of an even function, negative x, y, the x changes the sign, the y doesn't. What other point is guaranteed to be on the graph? Negative 3, negative 18. Perfect. So x changes sign, y stays the same. Both of those points would be on the graph. All right, these last two, true or false. If true, explain why. If false, provide a counterexample. So that means give me an example that makes it false. Number 12, all even functions go through the origin. What do we think? Think it's true? Still think it's true? There's the origin. You're just kidding. Yep, it's false. So, for example, that's an even function. Sort of. I drew it kind of bad. But it does not cross through the origin. If each term in a polynomial has an even exponent, the function is even. And that is true. Anytime you have a 2 and a negative 2, if you raise that to an even exponent, it's going to be the same. You're going to get the same answer. Now, every term, so you can't have a term that's just a single number. You can't have like a plus 5 at the end. It doesn't work because that 5 does not have an even exponent. But so every term would have to have an x with an even exponent. And that would make it true.